start talking about multiplying rational expressions by trying to remember how we multiply rational numbers. Okay, so a rational number is anything that looks like a fraction. We talked a lot about that last week. Okay, so give me two fractions. 1/2 and 3/4. Uh-oh. Oh, let me switch back to black. Okay, 1/2 times 3/4. Okay, and how do we multiply rational numbers? What do we do? Correct. We multiply numerators and we multiply denominators. Okay. And essentially, why does this work? Well, we're taking 3/4 and we're halving those. When we half those, we're taking half of 3/4. Well, now our little pies are, oh, we're talking about pi again. All of our pie slices are now 1/8 of the whole, and we have 3 of them. Okay? All right, so very good. I also want to talk a little bit about another example, because in this one we're done. But in another type of question, we may have to take an additional step after we do this multiplication. Okay, so let's say I have 5/8 times 6/15. Okay, so what would we do here? Yes? Say that again? Okay, yeah, so this can be simplified. Yeah, so you could do this simplification first. And that's what I want to talk about, actually. So you can totally simplify either one of them if they can be simplified. In my experience, most students do this, where they go, okay, 5 times 6 is 30. And 8 times 15 is 120, I think. Okay. Okay, and then at this point, what do we need to do? Simplify. So think of this as like 3/12. That's 1/4. Okay? So when you're working with numbers, this is a totally okay thing to do. You can multiply first and then simplify. Okay? But there is an alternate way of doing this. And I want to look at that because this is what we're going to have to do with rational expressions. Okay? So if we take this same thing, what I'm going to do is I'm going to break each of the numbers down into the smallest of parts. Okay? When I do that, what is that process called? Prime factorization, right? So 5/8 is 8 is 2 cubed. So 2 times 2 times 2 times 6 would be 2 times 3 over 15 would be 3 times 5, right? And Jackson, this is what you were getting at before about, oh, there's a factor of 3 in this second fraction numerator of denominator. So you could do that first. Okay? Now at this point, instead of multiplying numerators and multiplying denominators, I'm going to cancel all of the common factors that I see in the numerator and denominator, right? So, okay, that factor of 5 cancels. And I can cancel this factor of 2. And I can cancel this factor of 3. And so when I look at what's left, if I crossed everything out in the numerator, what's left? 1. And then in the denominator, I have 2 times 2, which is 4. Yeah. Okay? So there's 2 ways of doing this when we're working with numbers. You can multiply first and then simplify, which is what we did up here. Or you can simplify or think about factoring first, cancel the common factors first, and then multiply what's left. And that's the process that we need to use when we're working with rational expressions, right? Because we don't actually have numbers to cancel. We have factors of polynomials, okay? One thing I'll mention is that when we're working with polynomials as opposed to numbers, what we will probably write instead of 1/4 is 1/2 squared. Okay? So typically, once you multiply simplify, and then see what's left, you would write that sort of in factored form. Okay? So actually, I had 2 examples down here, but I'm just going to leave those because we've already looked at this quite a bit. Okay? Let's talk about how to do this with rational expressions. Okay? Now, the process is almost identical to the second thing we did. Okay? So what we need to do is factor everything. Factor all numerators and denominators. Okay? Now, here's where the little caveat comes in. Because when we're dealing with rational expressions, rather than just rational numbers, we have to think about something. If you know what I'm talking about, feel free to chime in. Or maybe go back and look at what we did before. Think about what you have to think about when you're working with rational expressions rather than rational numbers. There's an extra little step in there. Yeah. Can you say that louder? Right. We have to think about non-permissible values. So once everything is factored, we're going to state the non-permissible values. Okay? Once we do that, then we can cancel common factors. Okay? Now, I did get some questions last week about could you state the non-permissible values after you cancel. You can state non-permissible values at any point when you're simplifying an expression. But the non-permissible values apply to the original expression, not the simplified one. So if you want to do it at the end, you have to go back to the factored form and see what did I cancel out, because I have to count for that as well in my non-permissible values. Okay? So we're just going to practice this a lot. We're going to start with a relatively simple one. Okay, multiply the following expression. Now in this case, we're looking at numerators and denominators that are all monomials. When we're thinking about monomials, we can really just think in terms of our exponent laws. Okay? So firstly, everything's pretty much factored, right? We could, if we wanted to, we could expand out the x squared, and the 15 is 3 times 5. I know a lot of you guys were doing that, and it was a good strategy. But we don't need to factor anything here. So we have to think about now what are our non-permissible values. Yes. Yeah, 0, right? So if I look at my denominators, 5 is not going to give me any non-permissible values because 5 always equals 5. X cubed could equal 0 when x is 0. So my non-permissible values are that x cannot equal 0. Okay? All right, now, at this point, some of you guys will be able to just do this in your head. And if you can, go for it. Okay, so if you know, if you can do this in your head, do you know how this would simplify? If you have 15x squared over 5x cubed, what's going to happen there? 3 over x, yeah. So if you can do that, great. If not, remember you can always expand these guys out into sort of their quote-unquote prime factorizations. So 15 is 3 times 5, and x squared is x times x over 5 times x times x times x, right? And now you can see, okay, I can see every single individual factor. So I can cancel a pair of 5s, pair of x's, another pair of x's. And what we're left with in the numerator is 3, and in the denominator is x. Okay, now you don't have to show this step if you can do this in your head and think, okay, well, 15 over 5 is 3. And x squared over x cubed, 2 of them will cancel, 1 will be left in the denominator. That's fine. Okay? All right. Let's look at another example. Okay? Multiply the rational expression. All right, so in this example, what do we have to do first here? Give you a hint. It's the first step for anything with rational expressions. Factor, yeah. Okay, so numerator of the first guy, 4x plus 12. How can I factor that? Yeah. Yes, so we can take out a greatest common factor of 4. Okay? And then what about the denominator? Can I factor that? Yep. Okay, how does that one factor? 2, greatest common factor of 2, right? Yeah, and remember that in this course, the only type of factoring that is in this curriculum is greatest common factor and difference of squares, and possibly both. Okay, but you will not have to factor any trinomials. Okay, and then if I look at the second one, in the numerator, can I factor that? No. But one thing that I like to do actually is when I know that a binomial is fully factored, I like to put it in brackets just because it kind of prevents that urge to cancel part of a factor that we talked about last week, where if you see like an x in the numerator or x in the denominator, you can cancel them. That's only true if it's just an x and not a minus 7 in there as well. Okay, so you don't have to do that, but I like to. Okay, and then in my denominator, can I factor that? What's that? Yes, I can take out a 6. So I can take out a 6, and then 6 times 3 is 18. 6 times x is 6x. Okay? All right, what now? Yeah. Yes, state your non-permissible values. Okay, so what have I got? Yep. Right, so from this factor, x cannot equal 7. 7 minus 7 is 0. And from the second factor, x cannot equal negative 3, because 3 plus negative 3 is 0. Okay? All right. Now what? This is the fun part. Yep. We get to cancel. So I can definitely cancel these. Can I cancel the x plus 3 and 3 plus x? Yes. Order doesn't matter. Okay. Now at this point, some people like to keep going. But some people get a little bit confused when you keep going at this point, when you just have numbers left or perhaps monomials. So it's okay to regroup at this point and say, okay, what have I got left here? I've got a 4 in the numerator. And in the denominator, I've got a 2 times 6, which is 12. And then you can reduce that. Okay? So that would make 1/3. Okay? And, you know, if you struggle with reducing fractions, there's no problem to that. Like at this stage, I can show you how to do that on your calculator. If that's the only hurdle that you need to get over to do well in this unit, don't stress about it. We have a workaround. Okay? Some people also like to go, okay, well, if I just look at what I have left here, 4 over 2 is 2, and then 2 over 6 is 1/3. Right? So you can do that as well. But it's just try and think about what's going to prevent you from making mistakes. And if you try and do too much in one step, sometimes that can go sideways. Okay, so we're going to try another one, and then I'm going to get you guys to try some yourself. Oh, all right. Multiply the following rational expressions. All right, so let's start with the first numerator. What can I do here? Take out 2x. Yeah, there's a greatest common factor of 2x. Oh. And I'm left with x minus 6 over 15x. Okay? And then the second guy, okay, so 5x squared. If you want to write that as 5 times x, you can. I'm just going to leave it as 5x squared. What about the denominator? Yeah, there's a factor of 4, right? And you're left with x minus 6. Okay. All right, so what's next? Non-permissibles, right. Okay, so what do we got? 6 for sure, yep. X cannot equal 6. And what else? 0. Yes, because I have a factor of x. OK. What can I do now? Yeah, I can cancel some stuff. So there's definitely this factor of x minus 6 that cancels, so that's nice. And then I also have an x here and an x here, so I can cancel that. OK. And then there are going to be some numerical common factors as well. So if you want to do that in one step, you can. Or you can take a moment to regroup and say, OK, what have I got left in the numerator? I've got 2 times 5x squared is 10x squared over 15 times 4 is 60. Right? And then 10 over 60 is 1 over 6. So in the numerator, I just actually have x squared over 6. OK? One thing I just want to mention, because I saw some people doing this last week, and I just want to sort of give you a strategy that maybe you can use if this comes up, is I saw a lot of people who were partially factoring something but not completely factoring. So what I mean by partially factoring is, for example, the greatest common factor here is 2x. Maybe you just take out the 2. Or maybe you just take out an x, right? So if you just take like a, let's say, a 2 out here, you're going to have x squared minus 6x, right? Or maybe here you just take out a 2, and you're left with 2x minus 12. And here you take out, let's say you do this one correctly. OK? So I'm going to let you guys in on a little secret. We typically design these questions so that lots of factors cancel. So if you're seeing something that looks like, oh, I'm not getting anything that cancels, go back and check to make sure that you've fully factored, because that might be the problem. There's always the chance that I could just give you something where nothing factors, but it's probably unlikely. Probably something's going to factor. So go back and say, OK, I'm going to look at everything that I factored. Can I go further? OK? And actually, this comes up a lot when you have a greatest common factor difference of squares problem that's combined, where people miss the difference of squares. OK, so I want you guys to spend a couple minutes trying these 3 questions. So there's 2 on this page and 1 on the next. And then we're going to start to talk about division. So we're going to start talking now about division. And we look at multiplication and division at the same time because they're opposite operations. Okay? And in fact, there are some people who kind of are like, OK, there's no such thing as division. If you divide by 2, you can just multiply by a half. Right? So it's not like there's no such thing as division. But you can always state a division problem in terms of multiplication. And same with addition and subtraction. Right? You could go 5 minus 2 is the same as 5 plus negative 2. Okay? So we can really think of them sort of at the same time. Now, I want to talk first about how we divide numbers, or divide numerical rational expressions, or rational numbers, I should say. And then we'll talk a little bit about how to do this with rational expressions. Okay? So how do I do it? Let's say I have, I don't know, 2/3 divided by 1/2. What do I do? Yeah?
You flip the 2 over, the 1 over 2.
Yes.
To 2 over 1. And then?
Yeah, exactly. So what we do is we multiply by the reciprocal. Take the first one, multiply by the reciprocal of the second. So this is going to equal 2/3. And this was like what I was saying around being able to write division in terms of multiplication. Okay? So if you think about this, right? If you take 2 pizzas and you divide them into halves, how many halves do you have? 4. So you can think of 2 divided by a half is the same as 2 times 2 over 1. Okay? So this ends up being 4/3. Okay, so let's just try this with a couple more. We got 7 over 10 divided by 3 over 14. Okay, so we can start with the 7 over 10. And then multiply by the reciprocal of the second. Okay? At this point, we can do exactly what we would do with multiplication. So multiply numerators. 7 times 14, I think, is 98. Yeah? Okay. Over 3 times 10 is 30. And then what can we do at this stage? Divide by 2. Yeah, simplify. There's a factor of 2 in the numerator and denominator. So this is 49 over 15. Okay? Now, if we multiply first and then simplify, if we do that with rational expressions, we're going to run into the same problem as we did with multiplication. So what I would recommend doing, actually, is instead going, okay, 7 over 2 times 5 times 14 is 2 times 7 over 3. And then at this point, from the factored form, simplify. So I can cancel out a factor of 2, and then 7 times 7 is 49. 3 times 5 is 15. Okay? So that's the process that we're going to use for rational expressions. Okay, we'll look at one more. So 60 over 50 divided by 9/10. Okay? Now, if you recognize, oh, wait, I can simplify that one in my head, do it, right? 60 over 50 is 6 over 5. See, I would do that. 6 over 5 times, and then this will be 10 over 9. Okay? And then what we'll do with numbers, because this is what we have to do with rational expressions, is break this down into its prime factorization. 2 times 3 over 5 times, this would be 2 times 5 over 3 times 3. And then I've got, okay, a factor of 3 that'll cancel, and a factor of 5 that'll cancel, and that's it. And that, well, okay, so it's not 2/3, it's 2 times 2, 4/3. Yeah. Okay? All right, so we are going to do this same thing with rational expressions, but we have to still think about those pesky little non-permissible values. And when we're looking at division, there's an added layer that comes in. So I want to talk about that first. Okay? Let's say we are dividing these two rational expressions. Okay? As a division statement, what are the non-permissible values? Yes? You got it. Okay, so you got there right away, right? There's going to actually be an added, there may be, not necessarily added non-permissibles, because right now, our non-permissibles over here are x cannot equal 2 or -1. But as soon as we write this in terms of multiplication, sorry, I don't like using x's for multiplication when I'm using x's for variables. There we go. Okay. I now have an additional factor in my denominator of x. So I have to state that as well. Okay. So the extra thing you have to think about with division is that when you multiply by the reciprocal, you may get some additional non-permissible values, and you have to look out for those. And really, that is the only difference between multiplication and division in terms of, an extra thing to think about. Okay? So if I'm looking at this guy, simplify each quotient, I need to think again in terms of factoring. So one thing you can do if you want is multiply by the reciprocal and factor at the same time, so you don't have to write the same thing over and over again. Okay, some people just like to write the whole thing again where you're doing multiplication. I'm going to factor at the same time. So if I look at this, I can't factor x minus 5. Nothing to do there. Over here, how can I factor that? Yeah, there's a GCF of 3x. times x minus 3, okay? And then I'm going to multiply by the reciprocal at the same time as factoring. So I've got a 5, sorry, not a 5, multiply by the denominator will now be 5, okay? How do I factor this numerator, this new numerator? There's a GCF of 6. And I'm left with x minus 3. Now, what you have to remember is if you do this all at the same time, this 6 times x minus 3 was a denominator at some point. So you have to look in the second rational expression at the numerator and the denominator when you're looking at your non-permissible values, okay? Okay, so it actually isn't really going to matter in this case, though, because we already have the factor of x minus 3 here, right? So you don't have to state them twice if you have the same factor twice. You just have to make sure that you don't miss anything, okay? So here x cannot equal 0 and 3. Okay? And now we can do the fun part. So we can cancel this. And then can you guys see that 6 over 3 would be 2 over 1? Is that okay?
Oh, yeah.
Yeah? Okay. Well, it's okay with one person. Everyone else good with that? 6 over 3? Okay. So I'm going to cancel that as well and make that 2 over 1. And in fact, because the denominator is 1, I don't actually have to write that in if I don't want to. And now we're just going to kind of state the factors that are left. So if I look at my numerator, I've got a factor of 2 and a factor of x minus 5. Okay? And if I look at my denominator, all of this canceled. Oh, no, I didn't. X didn't cancel. So I've got 5x in my denominator. There we go. Okay. All right, so next, guys, so this is like a complex fraction. It's fractions within fractions. I don't particularly like them written this way when I'm doing simplification. Okay, so what I'm going to do is rewrite this where I have the numerator divided by the denominator. So this will be 2w over 24w plus 4w squared divided by 6w squared minus 6w over 9w cubed plus 54w squared. Okay. Okay, so now we got a factor. Okay, so this is a monomial. There's not much we can do there. In the denominator, however, what can I do? Yeah. Right, there's a GCF of 4w. Okay, and then 24w divided by 4w is 6. And then here we're just going to have a w remaining. Okay, now at this stage, if you want to multiply by the reciprocal and factor at the same time, that's fine, as long as you don't forget to check your non-permissible values. Okay, so this original denominator is now going to become my numerator. So let's think about how to factor that. Try and break it apart in terms of the numbers, the numerical coefficients, and the variables. Almost. So think, yeah, between 9 and 54, 9 is actually a greatest common factor there. Okay? Now, if you just took out a 3, that's okay, but just remember that if something isn't canceling, that you just look again and see if you haven't missed part of the GCF. Yeah, so there's a 9 as a GCF. What about the W's? How many can I take out? 2 of them, yeah. Okay, and then from here, all I'm going to have left is a w. And from here, I'm going to have 6. 6 times 9 is 54. Okay? And then in my denominator, right, the original numerator is now my denominator. How can I factor that? 6w, right. And I'm left with w minus 1. Okay? So just really important that you look here and here and here for your non-permissible values. Okay, so this is 0. X cannot equal 0. This guy is negative 6. This is 0 again. I'm not going to repeat that. This guy is a 1. And then if I have to look here as well, this is 0. I've already got that down. This one is -6, and I've already got that down. So I'm good. Okay? It's important to talk about why not to repeat them, because you will occasionally get questions that ask how many non-permissible values are there in this rational expression. Okay? And like if it's a written response question and you repeat the zeros, I'm probably not going to worry that much, but it would make a big difference in that kind of like how many non-permissible values are there type of question. Okay? So, all right. Let's cancel some stuff. So I can cancel these guys. Okay? I can cancel the W's. Okay? At this point, you may want to regroup and just like take a look at what's left. Okay? If you feel comfortable keep on canceling at this point, that's fine. But you may just want to regroup. Okay? Because sometimes, like in the previous example, as an example, I sort of lost that factor of x in all of my x's and slashes and all that kind of stuff, right? So you want to make sure not to do that. So I'm actually going to do that. I'm going to regroup. So if I look at what's left in my numerator, I've got 2 times 9w squared. So maybe I'll make that 18w squared. And that's it. Over in my denominator, I've got 4 times 6w. So that's 24w times w minus 1. Okay? And at this point, we can say, okay, well, what's 18 over 24? 3/4, yeah, it's 3/4. What's w squared over w? W in the numerator, yeah. And then nothing cancels with that. That's what we have. All right. Okay, so I want you guys to try the rest of these. There's 4 questions on this page and then a couple on this page. And that's going to be it for the rest of class.